Hello everyone. Welcome to Visual Application Programming Lecture Series, Lecture 2, Part 2, C# Operators. In this lecture, we will be discussing about the operators in C# and how we can use them in programming. Operators can be used to perform different actions on data. It takes one or more operands and return a result. There are many operators available in C#. These operators are denoted by different symbols and can be used in expressions to act on data. Few examples are plus symbol for addition, minus symbol for subtraction, brackets for indexing, parentheses for function call, etc. These operators take one or more operands and return a result. As you can see in this expression, operator plus takes 2 and 3 as operands, and this expression will produce 5 as the result. We can categorize C# operators as follow. Arithmetic operators, which are used to perform mathematical operations. Assignment operators, which are used to assign values to variables. Relational operators, which can be used to compare of literals and variables. Logical operators, which are used to work with Boolean data types and Boolean expressions. Then we have bitwise operators, which are used to perform operations on the binary representation of numerical data. Then primary operators, which includes member access and type checking. Then unary operators, which take only one operand as the input. Example operators of each category are listed in this table. Subtraction, addition, multiplication, division, modulus, increment, decrement belongs to arithmetic operators. Equals operator and many compound assignment operators can be grouped under assignment category. We will discuss the meaning of these compound assignment operators in a few slides. Is equal to, is not equal to, less than, greater than, less than or equal, and greater than or equal operators can be categorized into relational operators. Then we have logical category and conditional logical and conditional logical or, and not operators are included in this category. Bitwise logical and bitwise logical or, exclusive or, complement, left shift and right shift operators can be categorized into bitwise operator category. Then we have primary operators category, which includes operators such as member access, which is denoted by period, indexer access denoted by square brackets, invocation denoted by parentheses, type checking operator and null conditional operator are example operators in the primary category. Type conversion, unary minus, address of operator, pointer indirection operator are examples for unary operators. We will discuss many of these operators with examples in the upcoming slides. Some of the most used binary arithmetic operators are listed in this table. First operator is the plus operator and is used to do the addition. Example of addition is also given in the table. Similarly, we have subtraction, multiplication and division as binary operators. In the division, you can notice that if you divide two integers, the result is always an integer. So when you divide integer 45 by integer 2, the answer is 22 and not 22.5. Also, the result is always truncated towards 0. Modulus operator, denoted by percentage symbol, is used to compute the remainder. For integer operands x and y, x modulus y will return the remainder of dividing x by y. This can be expressed in mathematical terms as if q equals s divided by y and r equals x modulus y, then x equals q times y plus r. Arithmetic operators can produce results which are outside the range of possible values for the used numeric type. Few examples are: when integer arithmetic overflow occurs, it can throw either overflow exception or discards the most significant bits of the result. Integer division by 0 throws a divide by 0 exception. When integer overflow occurs, execution context decides whether to throw an error or ignore the error and continue. In a checked context, an overflow exception is thrown. In an unchecked context, when arithmetic overflow happens, the most significant bits of the results are discarded and execution continues. C# gives you the choice of handling the error or ignoring the overflow. By default, arithmetic operations executed in an unchecked context. Also, integral type cards can cause overflows as well. As an example, if you cast a long to an int, this may happen if the number is larger than int range. But bitwise operators and shift operators will not cause overflows. Also, you will not get arithmetic overflow or division by 0 exceptions for floating point operations, as floating point types are based on IEEE 754 standard and they have provisions for representing infinity and not a number value. Decimal arithmetic overflow always throws an overflow exception, and decimal division by 0 always throws a divide by 0 exception. The next category of operators is assignment operators. Assignment operator is denoted by equal sign and can be used to assign a value to a variable. Also, there are multiple compound assignment operators as well. Plus and equal denote add an assignment. In the given example, this will add the value of y to the value of x, store the result in x and return the new value. So it is equivalent to x equals x plus y, except x is only evaluated once. Plus equal operator can be used to add event handlers to events as well. Similarly, minus and equal operator can be used to subtract an assignment. There are many other compound operators available, such as multiplication assignment, division assignment, remainder assignment, AND assignment, OR assignment, XOR assignment, left shift assignment, right shift assignment. At the moment, you may not be aware of all these operators, but we will be discussing them in upcoming slides. Next category is relational operators. Relational operators compare two operands and return a Boolean value of true or false. Examples of How relational operators can be used is shown in this table. Less than operator compare two operands and return true if the left hand side operand is less than to the right hand side operand, or false if not. Similarly, greater than operator returns true if the left hand side operand is greater than to the right hand side operand, or false otherwise. Two equal signs denote the equality operator. It returns true if its operands are equal, or false otherwise. Less than or equals operator returns true if the left hand side operand is less than or equals to the right hand side operand. Similarly, greater than or equals operator returns true if the left hand side operand is greater than or equals to the right hand side operand, or false if left hand side operand is less than to the right hand side operand. Inequality operator is represented by exclamation mark and equal sign. This will return true if its operands are not equal, or false otherwise. Is operator also returns a Boolean value after checking if the evaluated type of an expression is compatible with the given type. We will discuss this further with an example in the demonstration. Next, we have logical operators category. Operands for the logical operators are only true and false values. They take Boolean values and return a Boolean result. Output of conditional logical and conditional logical or, exclusive or, and negation operators are shown in this table. Here, x and y denotes the operand values and output value after the operation is shown in respective columns. As an example, if both x and y are true, then x conditional logical and y is also true. But if either of operand is false, then x conditional logical and y is false. If you pay attention to the last column, you can see how exclusive or operates. As per the behavior of exclusive or, result is false when both operands are true or both operands are false. Also, you can use ampersand symbol and vertical bar symbol to evaluate and or operations, and the result is similar to conditional and conditional or operators. The difference is conditional logical and, which is denoted by two ampersand symbols, will not evaluate right hand side operand if the left hand side operand evaluates to false. Similarly, conditional logical or, which is denoted by two vertical bars, will not evaluate its right hand side operand if the left hand side operand evaluates to true. Next, we have bitwise operators. Bitwise operators work very similar to logical operators. Logical operators work with Boolean values and bitwise operators work with numerical values. We have bitwise AND denoted by ampersand symbol, bitwise OR denoted by vertical bar, exclusive OR denoted by caret symbol, and bitwise negation denoted by exclamation mark as bitwise operators. Result of each of these operators are shown in this table. Right shift operator and left shift operator can be considered as shift operators. Left shift operator, denoted by two less than symbols, will shift its left hand operand bits to left by the number of bits defined by its right hand operand. This Operation also discards the high order bits that are outside the range of the result type and sets the low order empty bit positions to 0. Right shift operator, denoted by 2 greater than symbols, will shift its left hand operand bits to the right by the number of bits defined by its right hand operand. If the left operand is int or long, then leftmost bits are filled with the sign bit. If the left operand is uint or ulong, then leftmost bits are filled with 0. The conditional operator, also known as the ternary conditional operator, evaluates a Boolean expression and returns the result of one of the two expressions. The condition expression must evaluate to true or false. If condition evaluates to true, the consequent expression is evaluated and its result becomes the result of the operation. If condition evaluates to false, the alternative expression is evaluated and its result becomes the result of the operation. Another important category of operators is primary operators. Member access operator, denoted by the period symbol, can be used to access a member of a namespace or a type. Null conditional member access returns null if the left hand operand evaluates to null. If left hand operand is not null, then it will work similar to member access operator. Square brackets are used for index operator. Usually, this operator is used to access array elements. Null conditional index access works similar to null conditional member access. If the left hand operand is not null, it works similar to index operator. Function invocation operator can be called using parentheses. Operator precedence defines which operators will be evaluated first. Some operators have precedence or priority over others. Operator precedence is not a new concept to you. In mathematics, we perform multiplication before addition. That means multiplication has a higher precedence than addition. The operators with higher precedence are calculated before those with lower. You can use parentheses to change the precedence, and like in mathematics, expressions inside the parentheses will be calculated first. This slide shows the precedence of the operator categories. Highest priority is given to the primary operator category. Then unary operators, multiplication, division and modulus. Then addition and subtraction. Then we have relational operators followed by equality operators. Then logical AND, logical exclusive OR and logical OR, followed by conditional and conditional OR. Next, conditional operator, and lowest precedence is for the assignment operators. When operators have the same precedence, associativity of the operators determines the order in which the operations are performed. Left associative operators are evaluated in order from left to right. Except for the assignment operators and the null coalescing operators, all binary operators are left associative. Right associative operators are evaluated in order from right to left. The assignment operator, the null coalescing operator and the conditional operator are right associative. Let's discuss an example to see how operator precedence works in a program. As you can see here, A and C are declared as float values and b is declared as an integer value. Result of the expression will be evaluated according to the operator precedence and evaluated value will be assigned to variable c. Then you can view the result in the message box. Expressions inside the brackets are evaluated first. According to the associativity rules, multiplication operator has the priority over division as that will be evaluated from left to right. So, value of b plus a will be multiplied by a and the whole result of the numerator is divided by the denominator value. And the output of this example is 105.8546.